Have you ever wondered why stars twinkle? A seemingly simple question, but one that has a fascinating scientific explanation behind it. As we gaze into the night sky, the stars seem to flicker and shimmer, creating a spectacle of light and mystery. What could be the reason behind this starry dance? Is it merely a cosmic coincidence, or is there a deeper, more scientific cause? Buckle up, stargazers and science lovers, because we're about to unravel this celestial secret. In this video, we'll walk you through the science behind this cosmic phenomenon. To understand why stars twinkle, we first need to know a bit about how light travels. Light is a fascinating thing. It's both a particle and a wave, and it has a mind-boggling speed of roughly 186,000 miles per second. That's fast enough to circle the Earth 7.5 times in just 1 second. Now imagine a star, a celestial body that's light years away from us. A light year is the distance light travels in a year, and it equates to about 6 trillion miles. So when we look at stars, we're actually seeing light that has been traveling for years, sometimes even millennia, just to reach our eyes. Light doesn't just travel in a straight line though. It can be bent, scattered, and even slowed down, depending on what it's passing through. This is because light travels at different speeds in different mediums. It's fastest in a vacuum, like the space between stars, but slows down when it hits a medium like glass or water. This slowing down of light as it passes from one medium to another causes it to change direction, a phenomenon known as refraction. But what does this have to do with stars twinkling? Quite a lot, actually. The light from stars has to travel through the vacuum of space and then through Earth's atmosphere before it reaches our eyes. The atmosphere is a turbulent place, with different layers of air of varying densities. As the starlight passes through these layers, it gets refracted multiple times, causing the light to take a zigzag path to our eyes. This zigzagging of light, combined with the vast distances it has to travel, is what causes the stars to twinkle. It's a bit like looking at a coin at the bottom of a pool. The water's surface distorts the light from the coin, making it appear as if it's moving or shimmering. That's essentially what's happening when we see stars twinkle. Now that we understand how light travels, we can delve into the reason why stars twinkle. Our planet's atmosphere plays a crucial role in causing the stars to twinkle. Let's delve deeper into understanding our Earth's atmosphere. Picture it as a giant protective bubble surrounding our planet. It's made up of layers of gas, held in place by gravity, and each layer has a distinct role in safeguarding life on Earth. This atmosphere is not just a shield, but a complex dynamic system that interacts with the light from celestial bodies, including stars. Starting from the top, we have the exosphere, the outermost layer, which merges into the vacuum of space. Beneath it is the thermosphere, where the northern and southern lights occur. Then we have the mesosphere, where most meteoroids burn up, followed by the stratosphere, home to the ozone layer. And finally, closest to Earth's surface is the troposphere, where all weather phenomena take place. Now, imagine the journey of a beam of starlight. It has traveled across vast cosmic distances, only to face the final hurdle of Earth's atmosphere. As this light enters the atmosphere, it begins to pass through the various layers of gases, each with different densities. This is where the magic happens. When light passes from one medium to another, it bends, a phenomenon called refraction. So as starlight passes through the different layers of our atmosphere, it bends multiple times and takes a zigzag path. This bending of light causes the star's position to appear slightly shifted. But remember, our atmosphere is in constant motion. Winds blow, temperatures fluctuate, and densities vary, causing the light to bend differently each moment. This rapid and random bending of light is perceived by our eyes as a twinkling star. This effect, known as astronomical scintillation, gives stars their characteristic twinkle, making our night sky a mesmerizing spectacle to behold. But in reality, stars are not twinkling at all. It's our atmosphere that's playing tricks on our eyes. So the twinkling of stars is not a characteristic of the stars themselves, but a result of our Earth's atmosphere. This twinkling effect has a fancy scientific term, astronomical scintillation. Now let's break down this seemingly intimidating term. Astronomical refers to anything related to astronomy or the study of celestial objects. Scintillation, on the other hand, comes from the Latin word scintilla, meaning spark. So, in essence, astronomical scintillation is the scientific way of describing the spark or twinkle we see in stars. But where does this twinkle come from? The answer lies in the ever-changing atmospheric conditions of our own planet. As light travels from the stars to Earth, it must pass through our atmosphere, a swirling mix of gases that are constantly in motion. These gases have different densities, temperatures and pressures, which cause the starlight to bend or refract multiple times as it makes its way to our eyes. Imagine the light from the stars as a group of marathon runners. As they race towards the finish line, they encounter a variety of terrains: flat, hilly, rocky, muddy. These terrains represent the different atmospheric conditions. Just as a runner's speed and direction might change based on the terrain, the light's path changes too, causing the star to appear as if it's flickering or twinkling. The degree of this twinkling can vary. On a clear, calm night, the atmospheric conditions are relatively stable, resulting in less refraction and therefore less twinkling. But on a windy night, or when the air is turbulent, the atmospheric conditions change rapidly, causing the light to refract more and the stars to twinkle more intensely. What's fascinating is that this twinkling is exclusive to stars. Planets, being much closer to us, appear as disks rather than points of light, which makes them less susceptible to the effects of scintillation. So, next time you see a star twinkling, you'll know it's due to astronomical scintillation caused by our own Earth's atmosphere. So, there you have it. The mystery of twinkling stars solved. We've taken quite a journey through the cosmos today, haven't we? Let's take a moment to revisit the highlights of our stellar adventure. We started with the basics of light travel. Remember that light, including starlight, travels in a straight line. It's constant, unwavering, and unchanging. But when it reaches us here on Earth, it's met with a bit of a challenge. Our atmosphere. Our atmosphere is a layer of gases surrounding our planet. It acts like a prism, bending and refracting the incoming starlight in different directions. This bending of light, known as refraction, is what makes the stars appear to twinkle to us terrestrials. The phenomenon responsible for this twinkling is called astronomical scintillation. It's the atmospheric turbulence causing the starlight to scatter, making the stars seem to flicker and dance. But remember, this twinkling isn't happening out there in the cosmos, it's happening right here, in our own backyard. The stars themselves aren't changing or moving, it's our atmosphere that's doing all the work. So next time you gaze up at the night sky, take a moment to appreciate the incredible journey that light has taken, from distant stars, through our Earth's atmosphere, to reach your very eyes. Remember, every twinkle you see in the night sky is a result of light's incredible journey from distant stars, through our Earth's atmosphere, to your very eyes. Thank you for joining us on this enlightening journey through the cosmos. If you've enjoyed this deep dive into why stars twinkle, we encourage you to share the light and send this video to those who might also find it fascinating. Don't forget to subscribe to our channel for more journeys into the mysteries of our universe. Together we can continue expanding our understanding of the world around us. And remember, keep looking up. You never know what you'll discover in the twinkling stars above.